Good morning, party people. So, howdy, it is 6 a.m.? 6 a.m. here in San Diego. Thanks, Francisco, for the Francisco Camacho. I like it. Just subscribed. Thanks for the subscription there. It's funny. I still got to figure out how to get all the little titles to work down around the bottom, around most recent follower, most recent subscriber. I commissioned Visuals by Impulse to go make me a set of custom stream overlays, but haven't heard anything back from them yet in terms of what the schedule looks like on that and how long it takes. So this morning, what I'm going to be talking through is my How to Think Like the Engine SQL Server series. I'm going to open up SQL Server Management Studio and just typing demo queries cold. I'm just going to be going off of either your questions, things that y'all go into, and I'm going to walk through. I've got a set of notes up here where I'm going to try to route you through my entire How to Think Like the Engine class. And there are no slides here whatsoever. It's just 100% demos. This also means that I can go off topic. Anything that y'all find interesting, we can go off and into and go from there. I originally scheduled this stream at like an hour long. I wouldn't be surprised if we went for like 2 hours, depending on what kind of questions y'all run into. All right, well, let's go ahead and get started. So we'll go straight into SQL Server Management Studio. Now, I'm going to be using SQL Server 2019, but everything that I'm going to show you is exactly the same going back through like the dawn of time. Nothing in SQL Server's behaviors really changed here. Then, Leo says, what are you drinking? I am drinking espresso this morning. I love the taste of espresso. It's just freaking fantastic. If I could drink espresso continuously, I would be totally all over that. I would probably never stop. Oh, I don't have the chat box turned on. Let me make sure that that's turned on so that your chats pop up in an overlay. Red Barrett says, hey, Amsterdam, yo! I feel bad because I actually did a training class yesterday and I wore an Amsterdam t-shirt, and now today I'm wearing an Amsterdam sweatshirt, so it's kind of weird how that works. Foodie for reals, yes. I should even move the chat box up just a little bit. Not the background, dummy. Should move the chat box up a little bit. Listen. Oh, do I have it locked? I have it locked. That's why I can't do that. Let's move that up just a little. There we go. That'll make more sense. Okay, so we have in a foodie. I also like just weird. I like bitterly tasting stuff. Like I like Guinness, for example. Most people don't like really bitter type beers or chocolates. I like dark chocolate. I could just drink straight espresso 24/7 if it didn't, of course, cause things like heart palpitations. And I know y'all probably think that like, oh, he's this excited or whatever because he drinks espresso. No, I'm always like this. I wake up at 2, 3 in the morning and I'm like, let's do this. I haven't had an alarm for years. Just we are like, I'm all dun, 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 dun. Then of course on the flip side is by 2 p.m. or 3 p.m. I'm like, I think I'm just going to go sit over there and have a nap. Hanny says, good afternoon, Brent. Good to see you again. Good to see you again, Hanny, there as well. So we've got our regular starting in here. So what we'll be doing is I'll be using SQL Server 2019, and I'm using the Stack Overflow 2010 database. Now, you could use any version of the database. I'm just going to use the small one just because a lot of people will use Stack Overflow 2010 because it's small. It's only like a gig in terms of downloading. It's pretty quick and easy. So the Stack Overflow database is provided by stackoverflow.com, totally open source. They're just wonderful in terms of the way that they give back to the community and make it really easy for people to learn. So howdy, Malik, good to see you again. So now I'll start running queries against it, and I've got the links up there up on the page too, and I'll go ahead and dump that out into the chat just so that y'all have it in case you want to follow along there with the demo queries. So let's get started. So I'm going to say select star from DBO users. I'm just going to go show everything in the users table. The users table at Stack Overflow holds exactly what you think it holds, a list of everyone who's ever logged into the Stack Overflow database, left a comment, posted a question, whatever. It's a fairly simple, straightforward table, and it has things like your display name, your location, where you live in the world, your website URL, how many reputation points you have. And the contents of it are up here on the screen. I want you to think of the stuff that's up here on the screen as like a printed out piece of paper. In a perfect world, when you do this class, you actually print out the PDFs, and they're available at that link. If you go over to brentozar.com, let me go put this into as well in the chat. If you go to brentozar.com/go/engine, you'll be able to get the exact printed out pieces of paper that I use. Everything in SQL Server, it actually changes a little when we get to things like column store indexes, but for the basics, everything that SQL Server does, it stores in 8K pages. And I want you to think of them as just like this up here, printed out on pieces of paper. That if you want to go find these things, if you want to go seek out users and show someone specific information, when SQL Server runs a query, your database engine, your MDF file, is just a stack of these 8K pieces of paper, all lined up in a row. If I want to see how much work it is to run a query, like the query I just ran, select star from DB or from users, I can turn on this option in SQL Server Management Studio called Set Statistics IO On. When I turn this on, it's totally safe. You can do it in production. It only affects your own session. From the time that I turn it on, I get something interesting over here in the Messages tab in Management Studio. There's this. It tells me for every page or for every table that I have, it tells me how many 8K pages I read. That's what logical reads means, the number of 8K pages that we read in order to accomplish this query. The more you have to read, the harder work it's going to be. Generally, query tuning means doing as few reads as we practically can. You can also see the execution plan, but we're going to get to that in a minute. 7,000 pages, it's about 15 reams of paper. You remember those dark old days when you had to go into the office, and over in the office there was a copier or a printer, and you would see people loading in these packs of 500 pieces of paper. That's a ream. This table is the smallest table in the smallest version of Stack Overflow, and it's already 15 reams of paper. So as we're executing queries, I'm going to have you come up with an execution plan in plain English, and I want you to think of yourself as a human being with 15 reams of paper over in the copier room with all this user data that looks exactly like what we have here. Now, how are these reams of paper organized? In the Stack Overflow database, they choose to do a clustering key or a clustered index on ID. That's this ID column, starts at 1 and goes up to a bajillion. It's an identity field. You've probably done something similar with your own tables. You've created an ID column and you've made it the clustered primary key. Sometimes people will say, what column is the clustered index on? In our case, it's sorted by ID, but the clustered index has all of the columns in the entire table. It's not like it just has ID, it actually has everything. Well, kind of everything. Over on the far right-hand side, for those of you who printed out the pieces of paper, there's a little About Me column. About Me is an nvarchar max. Stack Overflow lets people write a long letter to grandma in their About Me column if they want. You can put your entire resume, everything you've ever done. Well, that could be larger than an 8K page. So what SQL Server will do, if you get really wordy with your profile, is SQL Server will actually store your About Me on other 8K pages, and it'll just include a link, a pointer over to those other 8K pages where the rest of your data lives up on the page. This is called off-row data. And we're not going to dig into off-row data inside the span of this course, but I want you to get that when you do a big old nvarchar max, for example, there's a cost to that. There's a price that you pay whenever you have to go through and do those additional lookups to go get those other pages. So if I asked you to go select star from users, what would your execution plan look like? If I asked you to go through and say, go find all of the users and read the results back to me, well, if you're a human being, you would go over to that pile of paper in the copier room, you would grab the first piece of paper, and you would start yelling out the answers. And Dave says, a table scan. That's true, but think of it first in terms of what we're going to do as a human being. We're going to go to the top of that scan of copier paper and just grab them and start reading out the rows in order. Doesn't matter what order we hit them in. We could start at either end of the stack. Our goal is just to rip through all of them. Let's go see what SQL Server does. In order to see what SQL Server does, I'm going to turn on actual execution plans. We'll talk a little bit later about the differences between actual and estimated execution plans. But I'm going to go click that button, and I'm going to go run it again. And you'll notice that I get another tab when it finishes over in SQL Server Management Studio. So I'm going to zoom in here so that we can see this a little better. The way that we read execution plans is we read them from right to left. We read them, normally, you can read them in other ways. Sometimes during performance tuning problems, you may have to read them in the other direction. But normally, we read from right to left. We read in the direction that the arrows point. So the first thing that SQL Server did was it did what's called a clustered index scan, because this is the only copy of the table that we have right now. We'll have different copies of the table here in a while. Every one of these icons is like a mini program. Think of it like an app that you installed on your phone. And this mini program has inputs and outputs, and it works completely in isolation. It's almost like microservices. The output of this program, you can see if you hover your mouse over the plan operator. These things are called operators. And here's the output list. This is the list of columns that we're going to push up to the next operator. And in this case, it's just the select. We're just dumping the data out to the end user, and that's the end of it. But SQL Server puts a lot of interesting stuff inside up in here. For example, how many rows did I read? Right now, I'm dealing with the smallest copy of Stack Overflow, so we're talking about 300,000 rows. You'll hear that number come up repeatedly throughout the next hour. 300,000 rows is how many we read, and that's actually how many we output to. Number of rows read, 300,000. Number of rows for all executions is also 300,000. We read the whole table. We didn't have a where clause on this particular thing. Now, SQL Server also guessed how many rows it was going to read. We're going to come back to that in a while, but this estimate becomes really important when SQL Server is trying to figure out, for example, what it has to do in which order. So the first mini program goes through and has this output. It's going to output all these columns because we asked for select star. And if you hover your mouse over the arrow, in current versions of Management Studio, it tells you the number of rows that are moving through here. So I kind of just think of it as like a data pipeline that's going to move from one operator to another. So how expensive was this query? How hard was it in order to scan this table? Well, SQL Server makes a guess right at the beginning. If I hover my mouse over the select, SQL Server says my estimated subtree cost is 5.7. 5.7 what? Well, we call them query bucks. Kendra Little originally coined the term query bucks to represent the amount of work that's involved in a query. And it's a combination of CPU and I/O work. But this is just the estimate that was done before the query started. Where's that cost made up of? Well, if you hover back over the prior operator, because we only have one in this plan, so it's pretty simple. You see up here it says estimated CPU cost and I/O cost. When you go through and go to the copier room and you scan thousands of pieces of paper as you're reading through each of them, scan's probably a bad word to use since there's also a scanner probably in the copier room. But if you read through all of those 8K pages, part of that work is you pulling those pages. That's I/O. Part of that work is you looking at the pages and deciphering the rows and columns. That's CPU cost. CPU cost is really low in this case. Imagine if I sent you to the office supply room and I made you read 15,000 pages. You wouldn't be, 7,000 pages. You wouldn't be thinking that hard. You would just be doing a lot of reading. So in that case, this is the I/O. Sometimes when we're tuning things, we have to tune for CPU. Sometimes we tune to reduce I/O. But one thing to think about is that this estimated subtree cost is a blended number. Just gives you a rough idea of how much work SQL Server's doing in order to accomplish this query. A long time ago, back in the late 1990s, this represented the number of seconds that it would take to run a query on one guy's machine in Redmond. These days, those numbers are totally disconnected. It's just a rough, hard-coded number of how much CPU work and I/O work SQL Server thinks is going to be required. This will come in useful when we're doing query tuning, but it's also very misleading, which I'll talk about in a while. All right, well, it's really not that much fun to run a select star across an entire table. That's not really what query tuning is, and if our end users ran queries like that, we would probably shoot them in the face. So instead, let's go through and leave it to the American to say something like that. So let's clean up this query a little. Instead of getting all the frickin' columns, let's just get their IDs, and then let's put in a where clause. Let's say where last access date is greater than 2014-07-01. Last access date is exactly what you think it is. Thanks, Ankax. Last access date is exactly what you think it is. Every time that someone logs into Stack Overflow, posts a question, leaves an answer, Stack Overflow updates their last access date. So what I'm saying here is SQL Server, go show me all of the rows who accessed the system since July the 1st. Now, as a human being faced with a copier room with 15 reams of paper, with like 7,000 pieces of paper, in plain English, how are you going to accomplish this query? And I want you to type your answer in Twitch, but what I don't want you to do is say, I would build a B tree, I would build a doubly linked list, I would build a sort table, I would build a hash. No. You're a human being with 7,000 pieces of paper in the copier closet. How do you do this? Keeping in mind that the pieces of paper look exactly like what's on your screen here. This is the data that you have. You have 7,400 pieces of paper that look just like this. How do you execute this query? And just in plain English. Let's see what you come up with.
10, 9, 8.
Oh, you've already answered. So Dave says, I'm going to go through each row and keep the ones that we want and then discard but what we don't. I like Gringo. Gringo wants to outsource it. He's like, oh, I'd like to get someone else. Maybe I could post it on Fiverr. And Red says, I'm probably going to read them all. The thing to keep in mind is think like a human being. If I said, go get me all of the ones that match, you wouldn't want to keep them. Keeping them would mean writing them down somewhere, like getting a little piece of paper, a Post-it note, and writing them down. You don't want to. You want to get rid of them like hot potatoes as quickly as you can. So what you would actually do is you would go to the copier room and you would yell from there. You'd be like, Brent, heads up. I got ID number 500, 542, 546. You would just be yelling them. It's probably got a little deafening there over the webcast. You would be just yelling them out as fast as you can, and that's exactly what SQL Server does. So let's go through and run this query, and let's see what SQL Server does in terms of the execution plan. So now, this is the first time that we, and I like how you say this, so I'm going to call you H. And welcome back, too. It's good to see you again. So what you would say is you would put a ruler down through here. Well, just to be true, SQL Server doesn't store things nicely organized like this because it doesn't want to leave any extra white space on the page, so the rows would actually be jammed in as tightly as they could fit. So you would have to figure out where each row starts, but that's not much work for SQL Server at all. He's finely tuned to do this kind of thing. So I said each of these is its own little application. So the first application runs, and the first application is this clustered index scan. So the first thing that we're going to do as we're going through the closet is we're going to read through all of these rows, yelling out the answer. What's that next one? Oh, this is kind of cool. SQL Server will automatically parallelize stuff. This is just like Gringo said. Gringo said, I'm going to give it to other people to help. That's exactly what SQL Server does. Depending on how expensive this query is, SQL Server will corral in other workers and say, all right, everybody, we're all going to the copier closet together. And then SQL Server divides out those pages. Remember how we had like 7,000 pages that were in this table? SQL Server goes through and passes these out by thread, and you can see this. If I right-click on this operator and go into properties, I get a whole lot more stuff. I don't have to go into here very often during query tuning. Most of my work is actually out on the plan over here instead. But if you want to see every single detail about what every operator was doing, you can start to spelunk in through here, like the number of threads that each operator read. So SQL Server brought 4 people all together into the office closet and said, you take these pages, you take these pages. And SQL Server divided the work just like you would. You wouldn't be scientifically accurate. You wouldn't give exactly 346.2 pages to each person. SQL Server is just grabbing paper and slinging it out, roughly balancing the work. You can see that the reads aren't even here by all threads. One of the threads read 1,300 pages. Another thread read 2,200 pages. That's okay. It doesn't have to be exact. Something else that I find really intriguing is SQL Server can't assign who's going to find rows that match because he doesn't know what pages have an evenly balanced amount of people who've accessed the system since July the 1st of 2014. I can kind of see that if I start going into things like the number of rows. If I look a little further here, you can see how many rows each of the operators brought back. Not only were the input pages not balanced, but the output pages weren't balanced either. Because how do you know until you go open up all those pages from the office supply closet which pages have so many rows? So what SQL Server did was it took 4 people into the supply closet, came back out, and then there's this parallelism operator. Oh, I love these icons because they give you a rough idea of what's happening here. The parallelism icon is pulling all the results together from all these different operators so that then we can put it into one stream of output and shove it out the door to the end user who asked for the data. Yes, Havit H says the max stop is the maximum deployment of persons in the closet. I like that. That's actually quite good. Never thought of that before. I can appreciate that quite a bit, actually. And I've never said the closet term before either, so it's actually might work quite a bit. All right, welcome Richie. Richie's in this morning too. So this pulls in all these operators into just one row. This is a standalone operator. Dave says it is indeed operator. Interesting to see the logical reads on thread 0. I just got an idea for a blog post. Yeah, so thread 0 as the coordinating thread has to figure out which ranges of pages go to which threads. So cool. So then on the next arrow, all the rows go out the door. So it turns out that there were about 149,000 rows that matched, and those 149,000 rows go out the front door to the person who asked the question. So how much more or less work was this than the prior query? Well, one way to do it is to put the prior query, select star from DBO users with no where clause, put these 2 queries back to back, run both of them, and compare the number of reads that they did. If I go over here to the messages tab, SQL Server says that the first one read 7,405 pages. The second one actually read more, Due to the overhead of parallelism, breaking up, putting lots of people inside the closet, some of the pages are going to be read twice. That's okay. The results are still accurate. I don't want you thinking you got duplicated results. The first lesson inside here in this particular query is if you don't have something to make your query easier in the form of an index, if you ask for some rando column and SQL Server doesn't know how to get to it quickly, like here I'm saying where last access date is greater than 2014-701, I'm still reading the whole frickin' table. That's where indexes come in, and we'll talk about those in a while. That's one way to think of it, is looking at the number of pages that were read. That'll tell you roughly how much work was done. Another way to look at it is to look at the two execution plans. If I zoom in on here, the top one, if I hover my mouse over here and I look at the estimated subtree cost, the estimated subtree cost says 5.79. Then, if I look at the estimated subtree cost on the bottom, 5.87. It's actually a little higher because of the overhead involved with building parallelism, with sending multiple people into the closet. Sukir says, covering index all day. Sukir, I can tell that you're a developer because you want to index everything. And unfortunately, that's why you're here in the class. Your DBA sent you here because he was sick and tired of hearing you ask for an index when you really need to tune some of your queries. Then we'll talk about the differences between covering indexes too throughout the course of it. So you might compare these two and think that one is more expensive than the other, or one's cheaper than the other. But remember, those estimated subtree costs are just the beginning. That's before SQL Server actually executed the query. Sammy said, should actual rows be the same as estimated rows? In a perfect world, yes. But in the world you and I live in, not quite so much. And through the course of the next hour or two, we'll talk about what you do when those estimates start to diverge, when estimate versus actual is way off, and how you go about troubleshooting those. Okay, so nice at least here too that we've got this missing index request. Let's go take a look at just this one query by itself. So SQL Server has now piped up to say, and I always kind of think of these as like Clippy, the Microsoft Word Office assistant. I don't know if you remember, but there was this dancing paper clip that used to be in Microsoft Word. And he was like, hey, buddy, looks like you're trying to write a resume. Maybe I can help. Even when you weren't trying to write a resume, you're trying to build a shopping list. Well, Clippy got fired from the Microsoft Word team, reassigned, and now he works over in the SQL Server team. And he's all, hey, buddy, looks like you're trying to query by last access date. Maybe I could help. Clippy is razor sharp focused just on things like the where clause. He's not really concerned as much with, say, group by or order by. More on that later. But if you're following along, yours may not have looked like this. Yours may not have said, go build me an index. Yours may not have said, trust error, thank you, welcome to the club. Yours may not have said parallelism. Let's see why these things may not show up. What I'm going to do is I'm going to right-click on my SQL Server, go into Properties, and then I'm going to go into Advanced. And there's a setting over here that I can change. Cost Threshold for Parallelism. What this means is that the query must be this high in order to ride the parallelism train. Remember how when we were looking at estimated subtree cost, and I said that these queries were costing like 5.79 or 5.8? Well, what a lot of people will do is they'll change this setting, estimated cost subtree for cost, cost threshold for parallelism. They'll change this to a higher number. Let me show you what happens when you change it to a higher number, like, say, 50, which is a common setting that I recommend when I'm managing SQL servers. I'm going to change it to 50 and say OK. Then I'm going to run the exact same query again. And now my execution plan looks totally different. Leroy Jenkins. Oh, I never thought of it that way. That's pretty good. And that's especially when we get in things like table variables. So why not make all queries go parallel? Because sometimes you don't want, for example, when we were running this query just now, it finishes in like a second. Why bother throwing multiple cores at it? If I don't throw multiple cores, it'll leave other CPU cores free for other queries. And I always want to kind of balance that line. I don't want to have one bad SQL query just wreck the whole server. I want to walk a balance between letting people get enough resources, but not letting them wreck the whole server every time they run a query, because you know that one person in the office that writes really terrible queries, and you know they have access with SSMS. So the query looks different here. So here, I'm going to call him Leroy. So, yes, and now we know exactly who that was. And why doesn't SQL manage this cost automatically? I really love that question. Why doesn't SQL Server manage this for you automatically? Because it would be hard. And you haven't asked for it. Microsoft is just like you at your day job. You know how when you build something and you're like, your manager's like, I need a proof of concept of this by Friday. And you duct tape something together and it's made out of like Pringles and duct tape and chewing gum. And you're like, here, but this is just a proof of concept. Please don't put this out into production. And you know what happens next. They're like, thank you. We're just going to go deploy that now. We're going to put it in all of our shops later. Bye. And then it goes into production and you're like, I really wish I could have coded that and done a better job. And then later you want to go back to it and do a better job. But what does the project manager say? Hey, I got this new feature here. I want you to work on this new feature. No, forget fixing your crappy code. Let's work on this new thing. That's exactly how it works over at Microsoft. Now, y'all are asking a lot of interesting questions around parallelism and MaxStop. This is where I'm going to stop here for a second to take a break and say, I'm really just starting the first learning part of your journey. If you go to brentozar.com/training, and I'll put that link over there in the Slack, I'm really just starting your journey. This is literally the first course that you take with me. I put it right up at the top left here because it's really just starting your journey. And you can watch this again later. You can see blog post versions of it too. And then we get into things like the fundamentals of performance tuning, where I start talking about index tuning, query tuning, parameter sniffing, and server tuning, where I dig way deeper into stuff like cost threshold for parallelism, MaxStop, what happens when work isn't balanced evenly across all cores, and much more. However, I'm going to stop there. I'm going to put a place mark in that and just go, if you want to learn more about cost threshold, MaxStop, and so forth, how you tune for unbalanced parallelism, what the symptoms look like, that would be my fundamentals of server tuning class. But I'll stop there, and now we're going to come back to how to think like the engine. So I said, your query may not have looked like this. Your query may have looked more like this, where you just had a clustered index scan and no index hint. Holy cow, there are so many things that will make your query look different. The number of cores that you have, the amount of RAM that you have, your data distribution, your trace flags, your SP configure settings, your SQL Server version number, your build number, even every time you apply a patch can change the way that execution plans behave. So your next lesson there is that when you're going to try to tune queries, you're going to have a dramatically different behavior between production and development, between production and QA, even between production and DR. That's normal. It's normal to have different query plans throughout these environments because there are just very few shops that can afford to have exactly the same horsepower in production and then take that same horsepower and put it on every dev box. But I do want to just kind of throw that notice in there that sometimes as you work between different query tuning on different servers, you're going to see dramatically different plans. Here, I'm going to go back to the original default cost threshold for parallelism. I'm going to go back down to just a lonely little 5 so that as I go through and run this query, it more typically represents the kinds of query plans that you're going to see out in the real world. So here, SQL Server said, oh my God, I got to scan this whole table. It's going to be all kinds of, I always use a guy's voice for SQL Server because he's dumb and stubborn and refuses to ask for directions. He's all, trust me, I got this, when he doesn't usually got this. So SQL Server's all, oh my God, this is going to be so much work. It's higher than my cost threshold for parallelism. Guys, let's all go into the closet together and hold hands, or whatever it is that we do inside there. SQL Server parallelized it across multiple cores, and that's when Clippy kicked in. Clippy popped up and goes, hey buddy, oh man, looks like you're taking a lot of people into that closet there. You know what sure would help is if you had an index on last access date, you could do less work. Clippy's right, and we'll come back to that when we start tuning. Now, unfortunately, I can't do Jessica Rabbit's voice. I don't even know that I could pick her out of a police lineup, because it's been a while since I've seen Who Framed Roger Rabbit, and I should really go do that this weekend. That's a really interesting way to do it. All right. So we've got this select star going on, or select ID going on inside here. Let's add something else to the query that I bet you do all the time. I bet you do order by. So instead of just selecting from the from users, I'm also going to tack in order by last access date. So show me all the users who accessed the system since July the 1st, and then I want you to order them by last access date. Now, as a reminder, I'm going to show you the stuff that's inside the table just so that you can build your execution plan. You have 7,400 pieces of paper that look exactly like this. What's your execution plan for this query? And Leo, that's a great question, but I'm not going to go deeper into that. That'll be in my Fundamentals of Index Tuning class. So here, if given this query up at the top of the screen, and I'll make it even bigger just to make it easier for folks to see here. We'll pop it all the way up to 400%, and we'll put a line break inside there just so that y'all can see. So if I go through and say, go show me all of the IDs where the last access date is greater than July the 1st, now, how do you execute this query just in plain English? Let's hear what your execution plan is. Now remember, you got 7,400 pieces of paper over in the closet, and you can't change those pieces of paper. You can't write on those. You can hold on to them for a second, but you can't write on them. Yeah, so get all that data. Yeah, I get that. How are you going to do it? You're a human being. Be more specific than that. So thanks, Jason, and thanks, a tech guy. I'll give you all some time here.
10, 9, 8,
How would you do this as a human being?
4,
7,400 pieces of paper. How are you going to get them all sorted by last access date? And it'll help to look at the pieces of paper, to look at the table, because there are users, multiple users on the same page. Now, Red nails it. Read all of the pages, write down all of the records, and then sort them by afterwards. Yes. Now, Nikan's even closer. Nikan says just write down the user ID and last access date. Yes. Exactly. You are going to take your friends over into the office supply closet. You're going to hand each of them a stack of paper, and then you're also going to hand them empty pieces of paper. Maybe you're just going to go steal them from the office supply closet while you're in there. As you're reading through 7,400 pieces of paper, you and your friends are going to write down the ID and last access date of every row that you find. Now, some of us in here are developers might say, well, I'm going to sort as I go. That might make sense in some situations, but not in a database server where we're dealing with everything as a standalone microservice. So let's go see how SQL Server does it. Let's execute it. Let's go look at the plan. And now, the first thing that SQL Server did was scan all these rows. And as he was scanning them, he only output the rows that match. Remember, this whole table has 300,000 rows in it, but he only outputted like 150,000. Because sending your friends into the office closet, that's one standalone operation. If I hover my mouse over that, you see how there's a predicate down here. Predicate says, as you're going through the office closet, these are the only rows you're looking for. I only want you to return these rows. And when you're doing an output, here's what I want you to output. SQL Server has to do things like estimate how many rows are going to come back so that he can plan the rest of his work. Then, this little arrow right here, what this means is this is pushing 150,000 rows up the streams. Then, each of your friends is also going to do a sort. So the first mini program just yells out 150,000 locations. The second mini program goes back through here and sorts them by last access date, because that's what our order by was on. Then finally, the data gets coordinated across all your buddies who went in the supply closet. Gringo says, is a predicate the same as where? Yes. A predicate basically means here's what I'm looking for. I will say you can get predicates even without a where clause. We won't talk about that in this class. We talk about that in mastering index tuning. Okay, so how expensive, more or less expensive, was this one than the last one? We've got two ways we can measure queries, remember? We said we've got reads, so how many pages did it read? To see that, we'll go look over here, and it says we read 7,800 pages, give or take. So we read the whole table. Another way that you can see that is if I look over at the plan, if I hover my mouse over the clustered index scan, there's a thing up there. Man, you know, when Microsoft paints rows or paints stuff on a tooltip, they seem to use one of two approaches. They either put it in alphabetical order, which doesn't really make any sense for query tuning, especially when some of these have actual, some of them don't, some of them say estimates and some don't. It's not like there's any consistency inside here. They either put them in alphabetical order or else they load up the data cannon and they fire it at the screen, and wherever that data happens to randomly spread, that's where it spreads. This is an instance of the data cannon where the data is just scattered all over here in a way that makes no sense whatsoever. But the thing that I'm going to look for in order to see whether or not SQL Server read the whole table is up near the top, there's a number of rows read. Thank you for following, Epic Fail Drone. I love that name. That's just fantastic. Epic Fail Drone makes me think that you're going to have good videos inside there. So number of rows read, 300,000. That means we read the whole entire table. So in terms of reads, we spent about the same time in the office supply closet in this operator, but not the next operator. The next operator is brand new. That's the sort. And look at his cost. He's loving the data cannon. Of course, someone with a name like Epic Fail Drone would love the data cannon. So here he has a cost. See how it says cost is 99%? This is like 99% of the plan, because writing down all these freaking user IDs and last access dates and then sorting them is going to suck rocks. So this is what's a big, huge, giant new piece of cost. If you look at the CPU and I/O costs up here, you can see that they're so much higher than the cost of 5 that we had before, because sorting is hard work. It's hard work in terms of CPU. So not only is this query cost higher, if I hover my mouse over the select, you can see that the estimated subtree cost is now more than twice as high by adding an order by. Now our estimated subtree cost is 12 query bucks. We went from like 6 query bucks to 12 query bucks. But another thing that's different is the amount of CPU work required in order to do this. Now, Sukir, that is a really good question, and I'm going to hit that right after I talk about I'm going to hit it as a combination of here and what I'm going to talk about over the next like 60 seconds. It's a great question. I absolutely love that question. And it's beautiful because it really impacts the way that SQL Server builds execution plans too. So over here in stats, I get reads, but I don't get CPU time. I can add that though. I can say set statistics time on. I don't do this often because time is so changing. Now, I don't just mean like from a metaphysical perspective. I mean that sometimes queries will take a little longer, a little less time. It's not as predictable as logical reads. So it's not usually something that I tune for, but in this case, it's going to tell a story. Let's start with just the select without the order by. So with no order by, we're talking about, if I scroll down through this list, SQL Server spent 140 milliseconds of CPU time executing this query. So I'm going to write that over there in chat just so that we've got it. Then I'm going to go run the query again with the order by. So let's go tack on the order by and hit execute. And look at our messages again, and let's see how much CPU time was used. Aha, it went up. Now, do I worry about like 70 milliseconds worth of difference? Not usually. I mean, I've worked with companies who do. You take a Stack Overflow. Stack Overflow cares when you add on 70 milliseconds of CPU time per query. Most shops really don't. Gringo asked a good question. What's the difference between CPU and elapsed time? CPU time is how long you or how hard you worked. Elapsed time is how long it took. You can see a cases where CPU time is higher than elapsed because queries go parallel across multiple CPU cores. If you use 4 CPU cores for 1 second, for example, you'll see 4 seconds worth of CPU time only with just 1 second worth of elapsed time. The reason why elapsed time is so high here is because SQL Server Management Studio sucks at painting 150,000 rows into a grid. This is not what SQL Server Management Studio was designed to do. It's just not a fast client. So if you do this kind of thing inside an app, it'll end up going way faster. So what we've seen here is that this query has higher CPU time in order to do its work, because the order by is so much harder for CPU. This is where Sukhvir, man, your name is so cool. Now I got to go see, if I click on it, it doesn't say Sukhvir. I'm just going to call him Sukhvir. Or if you want, put in your pronunciation that you want, because I've seen you a couple times. I want to make sure that I get your name right. I suck really bad at names, but I can remember pronunciations, so I'll give myself points for that. Oh, Sukhvir. Oh, yay, I got it right. Oh, I got lucky on that one. I just got lucky. So Sukhvir, your question was so good because imagine that you sent your friends into the supply closet, and I'll come back to the execution plan. Imagine that you told them, hey, go scan through all of the rows, and I want you to write down the rows that match. Well, you wouldn't want them all to hand unsorted pieces of paper to you. That would suck. You want to delegate that work. So what you have them do is run these 2 mini programs. First, do this work of writing it down, then go sort all your rows. Then, when you turn your work into me, so that the icon on Parallelism where it's showing all the work coming together, as you turn your work into me, yell out your results in order. I'll correlate or I'll combine the results from each of you so that we're streaming them all together in one sorted list. I don't have to sort them all again. I just have to get them to behave. Sukhvir says this sounds quite close to Tim sort. I don't know who Tim is or what kind of sorting that he does. That's not true. I know a bunch of guys named Tim. I just don't know how they do their sorting. This is also why, so I didn't get my start in. I should stop for a second and say that. So in terms of my own personal background, I didn't get started with conventional going to computer science degrees type stuff. I just learned on the fly doing database work and went to all kinds of training classes around the world as I went through and did my database work. But there are so many computer science terms that I feel like I missed out on, doubly linked list, all kinds of stuff like that, where I'm like, okay, I kind of sort of know what that is, but the rest of the time I'm winging it. Talk about imposter syndrome. I totally have imposter syndrome out the wazoo. All right, so back over here on our demos. So the way that you tell how work was broken out is look at the parallelism stream operator. Everything downstream, I'm going the wrong way. Everything downstream from the parallelism operator was all done across multiple threads. So, and you can even follow it up the tree if you look at the work done by each operator. If you right-click in on the sort and you look at the number of rows, for example, here you can see the number of rows that each one of them sorted. So you can follow that work up the tree. In a perfect world, SQL Server balances it out. In a real world, sometimes the stuff gets unbalanced. And for those of you who are production DBAs, you might have heard the term CX packet, for example, which involves unbalanced parallelism. This is one of those cases where it can happen. So the order by made it way more expensive. The order by made this thing more than twice as expensive in terms of query buck cost. It made it about 50% higher in terms of CPU time. But when we were executing this query, I specifically said, what did you have to write down? And you said you were only going to, yes, Gringo says, is thread 0 a manager? Yes, it absolutely is. And you know how you could tell that it was a manager? Because it does less work than the rest. You like that? You like that? Made that up on the fly. Also, my employee is in here, so that's Richie, and Richie will be glad to tell you that I do less work than he does. He says, love that camera transition. Feels like I'm watching SQL Server, the game show. Next up, who wants to lose their query bucks? So we got this query cost now. We've added in an order by. What we'll do is we'll stop here and we'll take a bio break. We'll stop here for like, say, about 5 minutes. We'll stop for about 5 minutes, and then when we come back, I'm going to change one thing about the query. I'm going to change that select ID to select star. And I'm going to want you to tell me how that query is going to behave differently. So I'll see y'all back in here in 5 minutes.